The triangle proportionality theorem says that if a line is parallel to one side of a triangle and intersects the other two sides, so here's a parallel line intersecting two sides of a triangle, then it's going to divide the sides into segments of proportional length. Remember that proportional means ratios that are equal. So this segment, BE, is parallel to CD, which means it's going to divide the triangle into proportional lengths. So we can say AB over BC equals AE over ED. The way I look at it is I see this segment here as a fraction bar. So let's say I had 5 over here, 3 here, 5 here, 3 here. I could set up the proportion 5 over 3 equal to 5 over 3. Think of this as your fraction bar. It helps you to set up your fractions. So if we're shown that a segment is parallel to another segment in a triangle, then we can use that information to set up proportions to solve for missing lengths. So in this problem it says that in triangle PQR, ST is parallel to RQ, which is seen with these arrows. Then it tells us PT is 7.5, TQ is 3, SR is 2.5, and we want to find PS. So I'm going to call this X. So because these are parallel, we're going to set up our ratios and set them equal to each other. So like I said, think of this as one big fraction bar, and your fractions would be X over 2.5 equal to 7.5 out of 3. So they've already done the fraction setup for you. You just have to use it to solve for your missing side, in this case X. So of course we cross multiply. We're going to do X times 3, which is 3X, equal to 2.5 times 7.5, which is 18.75, and that equals 3X. And then we'll divide both sides by 3 to get a missing length of 6.25. Okay, so I would now like you to pause the video and, using that same setup, figure out the length of TQ. Press pause and see if you get what I get. Okay, and you should get the side length TQ is equal to 6. If you didn't get that, raise your hand or ask a neighbor. The converse of the triangle proportionality theorem just says that, so if AB over BC is equal to AE over ED, then we can conclude that this segment BE is parallel to CD. So we can say that the corresponding segments are parallel. So in this first example here, it's saying in triangle DEF, we have EH equal to 3, HF equal to 9, DG equal to 4, and GF is 12. So this time they give us all the missing information. Our goal is to determine if DE here is parallel to GH. So remember, if these are parallel, then their side lengths will be proportionate. So first we set up our proportion. And once again, think of this as one big fraction bar. So we set up the fraction 4 over 12 equals 3 over 9. So we're seeing, does 4 over 12 equal 3 over 9? So 4 divided by 12 is 0.3333 repeating. And we need to see what 3 divided by 9 is. 0.3333 repeating. So because those are proportionate, or the ratios are equal, then yes, we can say that DE is parallel to GH. Okay, so I want you to do the same thing with the second example. Pause the video and let me know, is DE parallel to GH? make sure your picture has the missing side lengths or has all the side lengths labeled. And no, DE is not parallel. I'm going to put a little slash through the parallel sign. Not parallel to GH, because if you set up the proportion, you get 7 over 14, and you're asking yourself, does 7 over 14 equal 6 over 10? Well, 7 over 14, if you put it in your calculator, 7 divided by 14, that gives you 0.5. And 6 divided by 10, that gives you 0.6. And we know that 0.5 does not equal 0.6, so these are not proportionate, so the lines are not parallel. You also have proportional parts of parallel lines. So if you have a set of parallel lines, 1, 2, 3 lines that are parallel, then you can say that the parts that they create, AB, BC, EF, and FG, are going to be proportionate. So they cut off their transversals, this transversal, proportionally. So once again, when you're solving for missing side lengths or you're looking for missing variables, you can think of this middle line as a fraction bar in order to set up your proportions. Then you have congruent parts of parallel lines, and that just says that if these 3 lines are parallel, just like this picture above, and AB is congruent to BC, then we also can determine that EF is congruent to FG. So you can do 2 things in this case. You can set up a proportion and say that AB over BC equals EF over FG. But then when you have the congruence here and here, you can also say that AB equals BC and EF equals FG. You can't do that up here because we aren't told that these are congruent, so we can't assume that they are. So in the first example where it says find x and y, we can do one of 2 things, but since they've combined the x's and the y's, and these 3 lines are parallel, and these 2 segments are congruent, our first step would be to follow the fact that these are congruent. So we would set 3y plus 8 equal to 5y minus 7. I would add 7 to both sides of my equation, and I would get 3y plus 15 equals 5y. Subtract 3y from both sides of my equation, and I'll get 15 equals 2y. Divide by 2, so I get y equals 7.5. Now, because JM is parallel to KP is parallel to LQ, and these 2 are congruent, we can automatically mark these 2 congruent. And so we can set up our second equation by saying 6x minus 5 equals 4x plus 3. I would add 5 to both sides of my equation. I would get 6x equals 4x plus 8. Subtract 4x from both sides of my equation. I would get 2x equals 8. So x equals 4. Okay, and here's another definition to add to your word bank. It's called a midsegment. A midsegment of a triangle is a segment with endpoints that are the midpoints of 2 sides of the triangle. So we see that this is the midpoint of this segment, and this is the midpoint of this segment. So that makes this guy right here the midsegment. And the midsegment of a triangle is going to be parallel to one side of the triangle, and the length of this smaller segment is half of the length of the bigger segment. So let me show you what I mean down here. So if this is a midsegment, and we know it's a midsegment because it's the midpoint of this side of the triangle and the midpoint of this side of the triangle. The smaller segment, x, is half of the bigger segment, 10. So the smaller segment is half of 10, 5. Or the other way you can do it is you can say that 2 of these segments, 2 of those midsegments is equivalent to one of the bigger segments. So once again, dividing by 2, we get x is 5, because it takes 2 5s to make up 10. So you can use either way to solve the second example. You can say that 2 of these midsegments equals one of the bases, or you can say that the midsegment, 2x, is equivalent to half of the bigger segment, 10x plus 12. If you do it this way, you have to remember to distribute the 1/2 to the 10, so that's 5x, and the 1/2 to the 12, so half of 12 is 6. So either way you decide to solve it, pause the video and see if you can get the correct answer. Okay, and you should have gotten that x is -2. If you didn't, or you need help, raise your hand or ask your friend. Alright, go ahead and start the practice worksheet.